We are, guys, I'm starting class. We are going to talk about zeros of polynomials today. Now, we know what a zero is. We did it before. We talked about it with like quadratics, and we were looking at it yesterday. There were some questions asked if something was a zero. What does that mean? Where it crosses the x-axis. So I'm asking, is this an x-intercept? Or is this an x value that makes your y equal 0? In terms of division, that means does it divide evenly? So the first thing that we need, actually I think I'm going to skip that one. This is what we were talking about yesterday, so I'm going to go to this slide. The factor theorem. We're going to go ahead and write this down. It says if you have a polynomial, x minus k is a factor, that means it divides evenly, if and only if f of k equals 0. Remember from our remainder theorem yesterday, we said you could just plug in that value to get the remainder. So if I want to know if something's a factor, all I really have to do is decide if we're So I want to know if the function 2x cubed minus x squared plus 2x minus 3 has a factor of x minus 1. So if I'm asking if x minus 1 is a factor, I am asking if it divides evenly. We have options for figuring that out. I could choose to do synthetic division and divide it. I could do long division and divide it. Or, what's the shortest option? Plug in. What would I have to plug in? Careful, we didn't put in the whole thing. We did 1. What makes x minus 1 0? That's a 1. So we figured out what f of 1 is. That was our remainder theorem yesterday. So I'm going to just plug in a 1. And what do we get? 0. So what that means is if you did divide it, the remainder is 0. Which means it is a factor. Okay, if I want to know if x plus 2 is a factor, what do we plug in? Get? Okay, so that means if you divided these, the remainder would turn out to be a negative 27. So is it a factor? No. Alright. I'm going to put one more up and I want everybody to try it on their own. I want to know if x minus 2 would be a factor of this polynomial. Plug in 2. It's always what would make the x minus 2 equal 0. So if you put in a 2, so we get you get 8. So what does that mean? Not a factor. Okay.
She's just a mastermind.
I was just thinking like 2 cubed is 8 times 4 is 32.
She's just a mastermind like that.
4 times 3 is 12, so you're at 20. Minus 16,
Can I
so
bring you
you're
to the
at
ACT
4.
with me as my calculator? Can I bring you to the ACT with me as my calculator?
Alright, let's try a different type. We are going to be factoring polynomials, but the first few problems I'm giving you a starting point. So factoring a quadratic, we had lots of strategies, check for a grades common factor, difference of squares, the slip and slide. But after that, if something wasn't a trinomial, really our only options for factoring were grouping. Is grouping going to get me anywhere here? No. If I try grouping 2 and 2 together, even if I take out my greatest common factor, I don't have like parentheses left. Remember, grouping only works if your parentheses are the same. So we are trying to get to the point where we can factor more complicated expressions like this. To start with, I'm going to give you a starting point. I am telling you that 5 is a 0 of that polynomial. If 5 is a 0, what does that mean? What would be the factor? X minus 5 is a factor, it divides evenly. So when I divide it, I would get a remainder of 0. It's a place where it hits the x-axis. So what we're going to do is I'm going to start out dividing. Now I actually have to divide it because I don't just care about the remainder this time. Since 5 is my 0, that's what I'm going to divide by. I'm going to do synthetic because I'm dividing by something linear. Okay. So 6 would come down. 6 times 5 is 30. Plus negative 37 is negative 7. Times negative 5 is negative 35. Plus 32 is negative 50. Times 5 is negative 15. Plus 15 is 0. Remember, I already told you that this was a 0. That means your remainder has to be 0. So if it's not, what does that tell you? You did your math wrong. Go back and fix it. Alright, but here's why this is so nice. Remember from yesterday, if I'm trying to write my quotient, that's my remainder, my constant x and x squared. We have 6x squared minus 7x minus 3. My goal is to factor. Is this something we can factor? Yeah, we've got it down to a quadratic, so now we can slip and slide. Multiply a negative 18, add to negative 7. Good. And then what do we have to do? Okay, so that gives 2x minus 3, 3x plus 1. My directions here, I told you to factor this. Okay, so you have to give me the total factored form. We have most of it, but I'm missing something. If I multiply this out, I get a quadratic. My original was an x cubed, so I need 3 parentheses. What's my other parenthesis? X minus 5. Because 5 is a 0, x minus 5 has to be in my factored form. So if I multiplied all 3 of those, I would get this original polynomial back. All right. Questions on that? Let's try a hard one. It's really not that hard. It just looks terrible. It looks bad, but it's not. I promise. You don't even know. Write the problem.
I don't know. That's the thing. I just got claw.
Okay. This is a polynomial. When at the end of that, I'm telling you k is 1 plus I. Okay, so that is my first 0. What did we do on the last problem when I told you 5 was a 0? We used it to divide. So if I'm telling you 1 plus I is a 0, I'm going to use that to divide. Now, in synthetic division, we leave off the x's, so we just write our coefficients. So we have a 2, a 3 minus 2i, a negative 8 minus 5i, and a 3 plus 3x. Okay, so I just wrote the coefficients, no x's. Now, how do we start our synthetic division? Back down to 2. When I take 2 times my 1 plus I, what does that give me?
2 plus 2.
2 plus 2i. Look how nice this is. What happens? I's cancel and I get 5. So now I have to take 5 times my 1 plus I. And what do we get?
Oh, yes. Okay.
5 plus 5i. And, lucky us, they cancel again. So we add and we get negative 3. Negative 3 times 1 plus I. And lo and behold, it's all 0, which we knew it had to be because I already told you that was a 0. So think of what we have left. This is 2x squared plus 5x minus 3. Is that something we can factor? Yeah. So we slip and slide. Multiply to negative 6, add to positive 5. 6 and negative 1. Divide back our 2. And we get x plus 3, 2x minus 1. I need my factored form. A good hint, if it's an x to the third, you're probably going to have 3 parentheses when you get down here. I have 2 of them. This is maybe the only part that we really have to think about here. If 1 plus I is a 0, think about when 5 was a 0, we did x minus 5. So if 1 plus I is a 0, we have to do x minus that whole thing. So it'd be x minus 1 minus I. Distribute your negative.
I'm just gonna leave this here because I am lost on 2 of them, so I can. Do you want me to come back at the end of the
it's
class?
gonna be x.
Like what time?
And then
Probably.
that,
Okay, thank you.
You're welcome.
because you have to bring down.
Okay.
I was not talking. Yes, you were.
Oh, you never stop talking. Okay,
I can't get clogged in every time.
take a look at this one.
I just talk to myself.
I know.
stop talking. I can't hear.
Alright, my directions are slightly different. I'm not asking you to factor it, I'm asking for the remaining zeros. Okay, factors and zeros are very closely related. If a factor is x plus 3, what's the 0? Negative 3. If the factor is x minus 1, the 0 is 1. So I'm asking you to factor it, and then set each parenthesis to 0 to find our zeros. So I already told you 3 was the first 0, so what do? We do our synthetic with 3. So the 1 comes down. 1 times 3 is 3. And 1 plus 3 is 2. 2 times 3 is 6. Plus negative 4 is 2. 2 times 3 is 6. And we get 0, which we knew we had to get. If you don't get a 0, please don't be that person that just writes a 0 there and goes on. Your math is wrong somewhere and nothing else will work. You have to actually find the mistake. So this is x squared plus 2x plus 2. Okay, remaining zeros. It was an x to the third, so there should be 3 zeros. I gave you one of them, we need 2 more. I need to factor this. So you say multiply to 2 and add to 2? No? But it's a quadratic. How do you solve a quadratic? Quadratic formula. You guys remember that? Opposite of b plus or minus the square root d squared minus 4ac all over 2a. So the opposite of b would be a negative 2 plus or minus the square root 2 squared minus 4 times 1 times 2 and 2 times 1. So I get 4 minus 8, so that's a negative 4. What's the square root of negative 4? Okay. So negative 2 plus or minus 2i divided by 2. If I divide everything, we get negative 1 plus and minus I. My directions, I just said give me the remaining zeros. Tell me the rest of them. I gave you the first one. The other two are negative 1 plus I and negative 1 minus I. So we found the rest. Can we try one on our own?
You're supposed to get 3.
Hmm.
You're supposed to get
There should be, if it's x to the third, there should be 3 zeros. We have negative 1 plus I, negative 1 minus I, and then 3 I gave you originally. So your highest exponent will be the number of zeros you get. Alright, you guys try this one. Did you guys have x squared plus 7x plus 12 after this and then? What does that factor into? My directions were to find the remaining zeros. I gave you the first one, 3i. So how do we find the other two? Set those equal to 0. What makes x plus 3 equal 0? Negative 3. And if x plus 4 is equal to 0, that gives you negative 4. All right. Any questions on this stuff? So what I want to end with today, we're going to write down a rule, we're going to practice it, but we will pick up practicing it more tomorrow. All of these problems we were able to do because I gave you the first 0, right? But what if I didn't? How could we get there without having the first 0 given to us? And to do that, we are going to use what's called the rational zeros theorem. I'm going to paraphrase this. I'm not going to give you the formal. Does that bother anybody if I don't give you the formal definition?
Yeah.
Okay. It tells me every rational 0 of a polynomial is of the form P divided by Q, where P is a factor of the constant and Q is a factor of the leading coefficient. This doesn't tell me every 0, it tells me the rational ones. So things that can be written as a fraction. It doesn't give me imaginary zeros, it doesn't give me things with radicals. It gives me the nice ones. And it tells me how those zeros have to look. It'll have to be something that divides the constant over something that divides the leading coefficient. And that has to do with what happens when you multiply things out. So we are going to do a problem. And I think I'm probably just going to have time for one of these today. And then we'll pick up with more tomorrow. Does everyone have the rule down? Okay. So, if you want, just write down this. You don't have to write down all the directions. We'll just label everything. So my polynomial is 2x cubed plus 11x squared minus 7x minus 6. And I have to somehow factor this and find the zeros without me giving you a starting point. So what we are going to do is make a list for the p, the q, and our possible zeros. Okay, based on what we just wrote down, what is p? It's everything that evenly divides this constant. So every number that divides 6, you could do 1 and 6, 2 and 3, right? And won't positive and negatives always work? Okay. It's kind of annoying, but you have to write positive and negative on all of these. You can put them in any order. But those are all the numbers that could divide by negative 6 without leaving me a remainder. Q is from my leading coefficient. What's everything that divides 2? 1 and 2. And couldn't they be positives or negatives again? Yes. Okay. Our possible zeros, based on that theorem we wrote down, that's p divided by q. Again, we have to keep the positive and negative. Every combination works. So each p divided by each q. So 1 over 1 is 1. 1 over 2. Okay, my next p value is 2. 2 divided by 1 is 2. 2 divided by 2 is 1. I already have it on the list, so I don't have to write it again. 3 divided by 1 is 3. 3 divided by 2. 6 divided by 1 is 6. 6 divided by 2 is 3. We already have it.
They're like 3 over 2 and 1/2.
They just didn't divide evenly because I did 1 divided by 2. And that keeps it like
So
this.
multiply each of the top ones, or divide each of the top ones by the
Yep, so I did 1 divided by 1, 1 divided by 2. 2 divided by 1, 2 divided by 2. Does that make sense?
Yeah.
Okay. What I just gave you is a list of everything that could work. Okay, how do I know if it works? If I plug it in, what does it have to equal? 0. So now it comes time to push a bunch of buttons on your calculator. Okay, now, my suggestion, I would try to save fractions for last. Okay, so when I plug these in, do you guys know some of your calculator tricks? Like if you hit second enter, it'll bring back what you just typed in so you can go back and change your number. So I am just going to start with like my 1. If I plug in a 1, what do I get? I get 0. We got lucky. We got it on our first try. All we need is one of them that makes it 0. Because if you have one of them, what can you do? What were we doing on previous problems? Once we found one that worked, we did synthetic division. So, could everybody in here have a different starting one? We know there are 3 actual zeros, so potentially 3 numbers on our list can work. So you don't have to start with the same one, but you'll get to the same answer. So we know 1 works because we plugged it in. So now we do our synthetic with 1, because we don't want to just keep plugging in numbers all day long. That's too time consuming. So 2 times 1 plus 11, 11. So 13 times 1 is 13. Makes that 6. And we got 0 like we expected. So that's 2x squared plus 13x plus 6. What would we do now? Slip and slide. 12. What multiplies to 12 and adds to 13? Divide our 2 back, so we get x plus 6, 2x plus 1. What else should be down here in this factored form? Well, 1 was a 0, so we need x minus 1. So this is my factored form. I also asked for the zeros. What makes x plus 6 equal 0? What makes 2x plus 1 equal 0? 1/2, and x minus 1 is 1. Were 6, negative 1/2, and 1 all on my original list of possible zeros? Yeah. So in theory, could I have got it by plugging those things in? Sure, but that's too much time. Once we have the first one, we can jump into our division. Okay, obviously these are not just two-step problems. Okay, there's a little more involved to them. We are going to keep practicing them tomorrow. I am going to give you homework, but I'm not collecting it tomorrow, I'm adding to it. The last 2 problems on this assignment are like this, so if you don't feel confident enough to try that yet, you don't have to. You can wait until tomorrow if you think you need some more class examples. But the first one, I think there's only 10 problems, so like the first 8 should be doable. So these last 2 are the ones like our last example. If you're not ready for those,